Hey learners, welcome to Mac. So learners, in this video we will see something about carry forward and a problem based on it. So in terms of coding, carry forward often refers to a technique which is used to optimize the solutions, particularly in dynamic programming and iterative algorithm. So in iterative algorithm, you can see its use in sliding window protocol and also in prefix terms. And in dynamic programming you can see that it is used in memoization and state transition. So now just see a problem based on carry forward, and using carry forward we will just reach the optimized solution. So now just see that there is given a string s, okay, of lowercase alphabet, and we have to return a count of pair ij indexes such that I is less than j and character at ith index of string is a and character at jth index of string is g. Okay, and one constant is here given that length of string will be less than equals to 10 to the power 5. So you see example of here of a string s. This is example of a string such as a, c, g, d, g, a, g. So you can see that from a we can just make a pair to g over here, and also the ith, if a is considered the ith index and g is considered the jth index, I is less than j. So such as this will make a pair, and this also from a to g. You can see that here a is ith at ith index and j is at jth index, and I will be less than j, such as this will also make a pair. And when we move forward, when we find a over here, and from there we try to find g to make a pair, you can see that this is also making a pair. And if a is at ith index and g is at jth index, so I will be less than j, so this will also make a pair of I and j. So like this, how many count is there for this? You can see that for this there is 1, 2, 3 and 4. So answer for this will be what? 4. Okay, so now just see another example, that this is also a string. Okay, now when we move in the string, whenever we find a, we will just try to find g to make a pair. Okay, so from here a to we will find g. So if we are finding g over here, so this makes a pair of I and j index. If a is at the ith index and g is at the jth index, I is less than j, so this will also make a pair. So from here you can just see that g is also over here, and this is also making a pair. And if a is at ith index and g is at jth index, and I is less than j, so this will also make a pair. Like this, you can also see from a to g over here, this also makes a pair. When we move forward, we will find again a over here. From here we will just try to find g to make a pair. So from here you can find that g is over here, this will make a pair. And when again we move forward, we will again find a, and we find g to make a pair, so we will find g over here. So what we are doing over here, whenever we found a character a, we just try to search for character g till the last of the string. So from a, whenever we encounter a g character, we will just increase the count by 1. Okay, and when we reach till the last index, we again from here we will again move towards the right to search for a. Whenever we found a, from there again we will try to search for g. When we find the g, we will increase the count, and we will go to the last index of the character. Again, when this search for the last character ends, we will start from here again to search for A, and when we will found A, we will again search for G to the last index character of the string. So we are just using this technique. So now just see that there is a solution given over here with this idea. Now just see that the pseudocode is written over here, that there is a function which is taking a string, and as the length of the string count is starting from 0. Now from I is equals to 0 we are starting the loop, and it will goes on to n minus 1. Then we are checking that character at the ith index is A. If it is A, then we are starting another loop from j is equals to I plus 1, and it will goes on to n minus 1, and it is checking that if the character at the jth index is G, then we will increase the count by 1. Okay, and then when this reaches to the last index, then this inner loops end, and then the outer loop again runs. Then it again searches for the character A, and whenever it finds the character A, from there again it searches for the character G by running the inner loop over here. Okay, so with this we will just get the count, and at last we are returning the final count. So we can see that what is the time complexity for it. So time complexity for this will be what? So just see that this outer loop is running for what? How many times? N times. We can see from 0 to n. So it is running for order of n time complexity. Now the inner loop, so the inner loop in the worst time complexity will run for order of n times. So what will be the final time complexity? The final time complexity will be order of what? The outer loop is order of n, and the inner loop is order of n. So since this is an inner loop, the order of time complexity will get multiplied with the outer loop. So the final time complexity will be what? Order of n squared, and this is a large time complexity. As you know that it is given that the length of s can go up to 10 to the power 5. So when the time complexity will be order of n square, so this will result in what? 10 to the power 5 to square, which is will be 10 to the power 10, which is a very large time complexity. So we have to optimize the solution. So if you know the optimized solution for it, just comment in the comment box, and now just proceed. So let's see another solution for it. So what we were doing previously, that whenever we found a character A, from there we just started the search to the last index for the character G. So instead of that, we can do one thing, that just to move from left to right, and see that whenever we will encounter A, we will just increase the count by 1. When now see that here is A, then we will increasing the count by 1. Whenever there is here A, we are increasing the count by 1, and till last it goes on. And we can do one thing, that whenever we found G, okay, just moving from the left to right, moving and increasing the count of A so far. And whenever we will found a character G, what it will do, it will just make a pair with all the previous A's, like this. From here to here it will make a pair, from here to here it will make a pair. So how many times it is making a pair? It is making a pair with all the previous number of A's so far. Okay, so from here you can see the answer is going on with 0, and whenever we are encountering a G, we will just add the A so far to the answer. So answer from, when the answer starts from 0, we will just add 2 over here. Okay, then we will again move forward. We are seeing that A is over here, we are increasing the count of A so far to 3. Then we are seeing G over here. What we will do then, we will just add the number of A's so far to the existing answer, which is 2 plus 3 will be what, 5. So now, because you can see that this G is making pair with this, and with this. Okay, so this G is making pair with all the previous A's so far. Then again we will move forward. We are again encountering a G. So what we will do, we will again add the A's so far to the existing answer. So existing answer is 5. We will add 5 to 3, and the answer will be what, 8. And here this is the last character of the string, so the final answer will be what, 8. So now just see the pseudo code for it I have written. Okay, so now just see that there is a method which is accepting a string. Here is a n for the string length. So here is count A for number of A's so far. We are starting with 0, and the answer we are starting with 0. Okay, now here the loop will start from I is equals to 0, and it will goes on to I n minus 1. If we found that the character at ith index is A, we are increasing the count A by 1, so we are just increasing the number of A's so far. And else if we found that the character that ith index is G, we will just add the count A to the answer. Okay, and at last, after this loop ends, we are just returning the answer. So with this we can get the optimized solution for it. And you can see this loop will run for how many times? This loop will run for n times. So the time complexity will be order of n. So the time complexity will be order of n. So with this we can get the optimized solution using the carry forward technique. Okay, so learners, this is it for this video. In the coming videos we will be seeing more problems which can be solved using carry forward technique. And if you like this video, click the like button, do subscribe to our channel. We will be coming with more data structure videos, and hit the bell icon. Thank you.